This workshop is to calculate, seeks to calculate the lattice energy of a hypothetical ionic compound, M plus Cl minus. And it gives us data to help us in this. So I want to review with you the steps that you need. So when you run into these things, you'll know exactly where to start. We always look at the formula first, because the formula tells us what the formation equation will be. The formation equation is describes the formation from the element. So M solid plus 1/2 Cl2 gas combining together to give 1 mole of MCl has a delta H of reaction equal to the delta H of formation of MCl. That's the kernel of this thing. And it is around that we build our cycle, and the cycle gives us the equation which we can solve for the lattice energy. Remember, the lattice energy is defined as the enthalpy change when just need some chlorine here. When 1 mole of M ions, cations, and 1 mole of chloride ions come together to form 1 mole of the compound MCl. So this is delta H of lattice. Okay, so we just have to complete the rest of the cycle. Midgets have been added again here. We have to complete the rest of the cycle so that we can write the equation of what delta H of formation is equal to. And we can do it in any order that we want. We might start off by taking metal solid and going to metal gas. And our equation up here says that that costs us 86 kilojoules per mole. So this is plus 86. And then we could go from metal gas to metal cation. M plus in the gas, plus 1/2 Cl2. We're not changing that right now. And of course that's the ionization energy. That's I1 of the metal. And I1 of the metal is indicated by this equation right here. M goes to M plus an electron in the gas phase. That's plus 409 kilojoules. Then we could take the 1/2 mole of Cl2 and make a mole of Cl from it. So then we would have M plus gas plus Cl gas plus an electron. Okay. Now if the electron and the chloride get together and form a chloride ion, then of course the energy change is the electron affinity of Cl. And that, according to this, is negative 355 kilojoules. So we have a number for delta H of formation on here as well. That's minus 435. So we can write the equation minus 435, the delta H of formation, is equal to the sum of all of these steps. Starts at the same place, ends at the same place. So minus 435 is equal to 86 plus 409. And the bond association energy is, I forgot to write it down, it's plus 242 for a mole, but we're only using 1/2 a mole. So it's 1/2 of 242. It would be 1/2 of the bond energy, and that's 121. Plus 121, take the energy to break a bond, as always. Then plus the electron affinity. Well, why don't we just put the number in? The electron affinity is minus 355, so plus a minus 355 plus delta H of lattice. And so we could solve the whole thing. Delta H of lattice here will be equal to, we've got minus 435 minus 86 when we take it over on the other side, minus 409 minus 121 plus 355. And if I did my arithmetic correctly, that gives delta H of lattice is equal to negative 696 kilojoules per mole of MCl. So each one of them is the same, but you have to look first at the formula. That tells us what ingredients there are for our cycle. And then we put together the cycle, write the equation, and solve for what we need.